Sir, we can start now. Yes, sir.
Hey, hi guys, welcome back to our streaming sessions on OpenTelemetry. Today's agenda is to have an explorations on the topic called as OpenTelemetry with the team Exam. Let me explain you what exactly, because you may not be maybe familiar with the term of OpenTelemetry. Let me explain you what exactly OpenTelemetry is. Whenever we deploy every application we produce to achieve certain objectives, considering some applications may be related to the e-commerce, some applications may be related to any informative, right? Or all the applications are going to deploy under the servers, right? So whatever the objectives by which we produce the applications, n number of users are going to connect to the applications and avail that all the features. Now, whenever users connecting to the applications or to the rather the servers, it produces various traces, metrics, and the logs. Is there is any way by which we can develop a data logs of this all the traces, metrics, and logs performed by the user on the application? We can use these all the data logs to analyze further maybe user behavior or any data analysis related to these kind of transactions, right, happens on the server. So if you want to analyze these all the data logs to produce any uh, predictive analysis, and for that reason OpenTelemetry is used. OpenTelemetry is an open source observability framework designed to provide developers with a unified way to collect, process, and export telemetry data such as traces, metrics, and logs from their applications. It enables comprehensive monitoring and troubleshooting by standardizing how observability data is gathered and processed. To know the key features of OpenTelemetry, first one is vendor agnostics. OpenTelemetry works with various observability backends. For example, Prometheus, Jagger, Zipkin, data logs without any vendor lock-in. Second, it provides unified data collection. It supports three primary types of telemetry data. One we already discussed about traces, represents a series of operations that occurs during a single transaction or request. Metrics means quantified data point, for example, CPU usage, request latency. It produces logs like records of events and with contextual information. Third is open standards, built on open standards like W3C trace context for context propagation, interoperability across systems. Fourth one is multi-language support, offers APIs for many programming languages including Java, Python, JavaScript, and more. Extensibility, customization through instrumentation libraries, processors, and experts. So overall, to avail various features of OpenTelemetry, Let me make this forum open for Team Axiom, who are going to give us the demonstration of everything, how, why, and what OpenTelemetry can do, and further we can use these all the data logs produced by the OpenTelemetry with analytical tools like a Splunk, and then how the entire process, how these application data logs can be used for analysis. That is the main objective of of these presentations. So over to Team Axiom, which will give us the guidelines on these all the topics what we are going to discuss. Right? Thank you.
Welcome everyone to this exciting session on OpenTelemetry. Today we are diving into one of the most transformative tools in the observability landscape. The subtitle says it all: standardizing observability across modern systems. Imagine a web of interconnected systems where data is collected seamlessly. That's what OpenTelemetry enables. Stick with us as we break this down into simple, actionable insights and even show you how it works in real time. Let's begin with the basics. What is OpenTelemetry? Think of it as a universal translator for observability. It is an open source framework that collects telemetry data like metrics, logs, and traces from applications. Instead of juggling multiple tools for monitoring, OpenTelemetry offers a unified approach. It is supported by the CNCF, making it a trusted choice for developers and organizations worldwide. Imagine it as the central nervous system for your application observability. Let's take an example: tracking the performance of an e-commerce app. OpenTelemetry gathers data on load times, user interactions, and even payment processing all in one place. Now, why should you care about OpenTelemetry? It simplifies observability. For example, if you are running a distributed system with dozens of microservices, managing logs and metrics manually can be overwhelming. OpenTelemetry centralizes this process, eliminating vendor lock-in. It helps you debug issue, monitor performance, and identify root causes effortlessly. In short, it saves time and ensures your system runs smoothly. Think about identifying a slow checkout process on an e-commerce site. OpenTelemetry pinpoints the exact microservice causing the delay, making troubleshooting a breeze. Now, the question arises: where can you use OpenTelemetry? Practically everywhere. It is a must have for cloud native environments like Kubernetes, microservices, and serverless setups. It is ideal for monitoring application performance, ensuring system reliability, and even improving user experiences in DevOps pipelines. For instance, a streaming services like Netflix can use OpenTelemetry to monitor playback performance across different regions and devices. Let's talk about features. OpenTelemetry supports multiple languages like Python, Java, and Go, so it fits seamlessly into any tech stack. Its pluggable exporters let you integrate with your favorite tools, and auto instrumentation simplifies the setup by eliminating the need to modify your code. Plus, its scalable architecture make it perfect for handling large and complex systems. Now, you might think, why is OpenTelemetry a game changer? First, it is open and vendor neutral, giving you flexibility. It creates a unified telemetry pipeline for metrics, traces, and logs, reducing complexity in distributed system. And the best part, it's community driven and extensible, ensuring it evolves with your needs. Think of it as having a universal remote for all your observability tools, saving you from switching between different devices. Now that we have seen the advantages of OpenTelemetry, it is time to explore the other side. My team member will take you through the challenges, disadvantages, ethics, and more. Stay tuned.
Thanks. Let's dive into the challenges and see if OpenTelemetry is as flawless as it seems. But it's not all sunshine. OpenTelemetry does have its challenges. It had a steep learning curve for beginners, and since it's still evolving, some features may lack maturity. There's also a performance overhead in heavily instrumented systems. Slow. Planning your observability strategy is crucial. Adopting OpenTelemetry isn't without hurdles. Integrating it with legacy systems can be tricky, and storing and processing large amount of data efficiently requires careful planning plus choosing the right observability. Backend and balancing granularity with performance can be challenging. OpenTelemetry has its limits. It doesn't include storage or visualization tools, so you will need additional setups. The initial configuration effort can be high, but once in place, the benefits far outweigh these challenges. OpenTelemetry shines with its integration. It works seamlessly with backends like Prometheus, Grafana, and Jaeger. On cloud platforms, it integrates with AWS X-Ray, Google Cloud Trace, and Azure Monitor. At the heart of this ecosystem is the OpenTelemetry collector, which aggregates and processes data centrally. Before wrapping up, a quick note on ethics. Always ensure data privacy and security when using OpenTelemetry. Optimize your data collection to avoid performance bottlenecks and adhere to regulatory standards like GDPR. Responsible observability is key to sustainable operation. In conclusion, OpenTelemetry is revolutionizing observability in modern systems. It simplifies monitoring, enables better debugging, and ensures system reliability. While challenges exist, its benefits make it a must have tool in today's tech landscape. So far, we have explored what OpenTelemetry is, why it's important, its advantages, disadvantages, challenges, and much more. I hope the session was insightful and gave you a clear understanding. But we are not done yet. My team member is ready to take you through an exciting session where we will see the installation process of OpenTelemetry right before your eyes. And that's not all. After the installation, we will demonstrate OpenTelemetry in action. So stay tuned, it's going to be amazing.
Uh, in this section, we will see the installation process about the OpenTelemetry in Windows. First, let's open the Chrome browser. First, we need to install the OpenTelemetry connector to run the OpenTelemetry in Windows. So, we will search OpenTelemetry collector. Here we see the official website of OpenTelemetry collector. We will click on it. Mm, Here we see the sidebar is the install the collector. We will click on it. We are downloading. We are installing for the Windows. So we go to the Windows section. Here we see for Windows we have to download the latest releases. That is we click on it for that. Uh, the OpenTelemetry collector latest releases. Here we see we can download from here. That is a zip file. Uh, as I download already, so we will see the folder structure of that. Mm, Here we see the OpenTelemetry collector files. So we'll click on it. There are many files in that. We can see the OpenTelemetry collector have the CMD component, configs, and many more. Uh, there are two necessary files that we have to install from external sources. That is makefile and the hotel country file. So we will download from here. We will close here. Close. Uh, we will search for hotel country file. Hotel country. Here we see the GitHub's official website, that OpenTelemetry country file. We'll click on it. Mm, Here we can download the file from here, from code section. Click on it. We can download the HTTP link from here, or we can download the zip file from here. Uh, as I download already, so we will set the path to run the OpenTelemetry collector. We'll close first. First we will open the OpenTelemetry folder. Uh, okay. Here we have to set the path of hotel country here in the folder. So to run the OpenTelemetry collector, uh, here is the file. So I have copied the file path. Then goes to the environment variable. We'll search to set the path of hotel country to run the OpenTelemetry collector. We'll open it. Then goes to the environment variable. After that, in system variable, we see the path section. We'll click on it. We have to click on new button. So we have to give the path of hotel country. I will yes. Here we see the path of hotel country .exe file. We have given the path to run the OpenTelemetry collector. We'll click on it. Okay, okay, and then okay. Here we see after that the necessary file has installed. So we'll open the VS Code. Here we see the hotel make file and the hotel country file is there, is successfully or not. Here we see the hotel country.exe file is successfully visible here to run the OpenTelemetry collector, and hotel config file is also necessary to run the OpenTelemetry collector. And OpenTelemetry collector, there are several responsibilities that config file in that the receiver, processor, and exporter. Um, so we see the receiver. We in receiver section we see the data of getting the data from the servers, logs, and many more. In processor is something batching allow us to batch the process. So after that, the exporter will give the destination of the data. So for to the final destination where the data is visible in the form of logs and metrics and traces. My teammate will give you a further demonstration how the hotel collector working process in details.
So, hello everyone. Today I'm here to demonstrate the OpenTelemetry. So as my teammate will demonstrate that how the file structure will be created. As you can see, I have created the hotel contrib dot. I have inserted the hotel contrib .exe file from the external sources. I also added a make.exe file. So we'll now go to the VS Code editor. Here you can see our file structure. And so first of all, the workflow is we have first of all we need to install some packages for creating the setup, and then we need to create a config.yml file, as you can see here. So uh, now we can see that uh, this is the file which we have created previously, and here you can see some packages are installed for execution of the file. There are some packages like csv, random, date, time, logging, and request. So for executing the OpenTelemetry collector, so we need some packages which are such as OpenTelemetry SDK, OpenTelemetry API, and OpenTelemetry gRPC IO, and OpenTelemetry Exporter OTLP. So these are the packages which we need to install, as I have previously installed that packages. So we can see the packages are, as you can see, we have successfully installed our packages as OpenTelemetry SDK, the version, the summary, the home page where we uh, extract or clone or fetch the SDK package. So uh, now we will uh, yes. So after the importing the packages, we need to give some variables on the file, which has exporter, log processor, log emitter provider, and we need to add some functions for making this code is as simple as possible, as code console log exporter functions. So now we need to set the variable as handler, and handler has the uses handler is using a function as logging handler, logger provider equals to log emitter provider, which means uh, the SDK logs are getting handled by this function. And now we set the configuration that what we want to uh, what we want to get our data get in our data. That's the logs levels, source IPs, so user IDs, messaging, and num logs. So these are the fields which we want to get in our data. As you can see that log levels to messages. And now num logs is the number of logs which we want to generate in our file, as num logs equals to 100. That is, we are getting our data on the 100. We are getting the 100 number of data in our file, and we also created a output file path variable, which is used for fetching the data from this file. As you can see, we have previously generated the data. So what I'm doing is I'm deleting this data, and uh, log generator.py file, we need to after getting the data we need to integrate the OpenTelemetry collector with Splunk. So for integration of Splunk, we need some URL or token. So here you can see that Splunk HEC URL. HEC stands for HTTP Event Collector. So event collector URL, and the URL is also known as the of the endpoint of the data collection. And here you can see that Splunk HEC token. So token is generated on the Splunk as we can get our HEC token by uh, on the settings tab, and after on the settings tab you can see that there is a type of local input which is HTTP event collector. So from there you can get the HTTP HEC token. So as I have previously created, we can also create a new token as giving the name of the token, source name override, and that's optional. You can also give that. So indexer. So as I have previously created that, you can see that this is the token value which we need on our log generator.py file. So now we have created some functions that generate log entry. These are the fields which we want to get. If any exception is occurred, then it will simply display the message as failed to generate log entry. We also created some functions that write logs to CSV, that we want to set the path of we want to set the file format of it, and then after that we create a send to Splunk function which is used for integrating the Splunk. So and after that this is the function for sending that data from to this output file path. As the output file path is the variable which I uh, declared previously as this output file path is open. Now we run the now we execute the file. This may take some time. As you can see that it is successfully created, and now you can see that our data is successfully generated, and our data, the number of our data is 100, as first line contains the field's name. So now we can check, now we verify that our data is successfully fetched on Splunk or not. So we simply go to the search and reporting, and we simply write the SPL query. So SPL stands for the uh, processing language, and now we execute the query as index equals to hotel logs. As you can see, we have successfully fetched our data. Index equals to hotel logs. If we want to uh, uh, if we want to execute some basic filtering on the data, so we need to write some message SPL queries, that for the if we want to retrieve our logs for a specific user, we need to add some set SPL queries as user equals to user ID, equals to user 1 or user 2. As I'm getting the data of user 3, so index equals to hotel logs and user ID equals to user 3. Here you can see the user 3, the data about the user 3. Now, if we want to retrieve our logs from specific IP source, so we simply write as source IP equals to here 1.3. So source IP equals to 1.3, and you can get the data as well. That 39 events are happening here, and the source IP is this. You can see that. Now, if we want to retrieve our logs from the for the specific keywords in log messages, so we simply write as index equals to logs, hotel log, sorry, and logs messages equals to login successful, or we can get the data as file uploaded. Here you can see that we successfully fetched our data that contains the message log message as file uploaded. So if we want to perform some advanced